help support our coverage using Blueberry, the community that gives creators the ability to make money, get detailed audience measurements, and host their audio and video. Get 30 days to try out the service using promo code Blueberry004. That's BLUBRRY004.
All right, everyone. So this is one of our first demos we've had, believe it or not, here at the show. So I want to welcome Hassan from Archie Tech. He's the CEO of the company. Go ahead, Hassan, and tell us a little bit about the company and what we're going to see here. Oh, we got to get him mic'd up. Okay, go ahead.
Yeah, so it is ArchiTek.
ArchiTek, okay.
So the first word is from architecture.
Okay.
And the last word is technology. And it's combined to, the architecture. So what we are actually doing is we're making a chip. It's a small LSI. And it goes to power like intelligent AI applications running on battery.
Okay.
And handheld devices. So just think of, your cell phone or a mobile phone, which is intelligent enough to identify objects.
Right.
Something like that. And yeah, I have a demo, and I think that's the easiest way to see what we are offering.
Yep. Go ahead and talk about what we're going to see here.
Yeah. So can you see this demo?
Yeah.
Yeah. So he's the CEO of ArchiTek.
Okay.
And he has this small camera over here.
Yep.
And this has the chip, the brains inside.
Okay.
So it's a very small piece of equipment.
Yep.
And this is being powered by a battery pack.
Sure.
And it is actually running an AI application which can actually detect people or objects.
Okay.
If you maybe want to put your water bottle in front, it will show your water bottle on this monitor.
Yes, it does.
We can bring up our PTZ cam over there. We should be able to zoom into that and see what it looks like up on screen, because that's pretty nifty. Now, what are the applications for this technology? What are you looking at?
Yeah, so many other people are actually doing something similar, but they are mostly doing it in the cloud, using servers, very powerful servers. So we have a handheld solution which uses very little power. So this can be used for like many different applications. One application that comes to mind is drones, where it's running on battery. And it doesn't have too much battery because it has to fly.
Sure.
So it doesn't have much to actually, detect objects. So it can bump into anything.
Yeah.
Sure.
So if you are having a self-flying drone, you want it not to bump into things. So this is one way, you can avoid obstacles like that.
Sure.
So does it actually do the identification? Does it tell you that's a water bottle, that's a person, or just does the detection only of the object?
Well, detection is the most difficult thing, because it's a camera and it doesn't really know what a person is or a car is.
Sure.
So detection is the most difficult part, and it requires a lot of computation power. So that's what we do. Later on, how to avoid that. That can be done using another application. It's just software related.
Sure.
It's not such a big thing.
But it's the actual detection within the camera being able to focus in. Like what we see here, folks, is as the camera is showing the water bottle, we can see it's circled up on it, and basically then you would take that information in a different application, and then the different application would say, okay, that's a water bottle.
Yeah.
So in other words, what we've been here, and you could probably within this software as well, you could take a snap at this point of that particular object and put it in. If you're running an additional software application, you could do the snap and say, okay, we've captured that. Let's identify it later. That's very interesting. So, what are I guess for a better word, what are the limitations of the object detection?
Of course, one of the limitations is it goes for any AI application, but you have to train the AI engine. So someone has trained actually to detect approximately 90 different objects. So if you have more than that, and in the world you have so many objects, so you have to train for that, and you have to build the model, and that requires a lot of effort.
Yeah.
So depending upon the customer, of course, we can try to build that model, but we normally leave that to the customers. We don't go into that area. What we focus on is if we have the model, then we can infer from that.
I got you.
And tell him the results.
I see.
Yeah.
So if the model is basically, I need to see people, I need to see bags, I need to see whatever the list is, then you train the system to see those particular objects.
Yeah.
Oh, so that's really cool.
Yeah.
Because if you think about, you could almost train this to see a knife, see a handgun,
Absolutely.
see
facial recognition
see
in
different
crowds.
see different types of things that you're looking for
Yep.
Yeah.
that you want to catch, or maybe it's you have to actually physically see it. So wow, there's a whole host of things that's very, very cool. And the best part is it's just running on a chip that, again, while you're wearing a vest, this could go in a very small application on a camera pointing at a hallway or something.
Exactly.
Yeah.
So, like, you may get an idea. It could be used for the police force.
Yep.
Something, they wear something similar.
Sure.
So, and they can, as you said, they can detect guns or, dangerous items.
Yeah.
So then they don't have to keep on looking. The camera is looking for them.
Yeah.
It relieves their burden on that point.
I was just about to say, specifically the Secret Service and people like that who come in and patrol the same place every day, and they're looking for suspicious objects that weren't there the day before.
What's the size limit then? What's the detection limit from a size standpoint?
So that, I think, goes again into the area of the camera's capacity.
Yep.
So we have provided a very economical solution. So we have not used a very high quality camera.
Right.
But even then you can see it detects a lot of objects at this range.
Sure.
So if you have a better camera, if you have a camera which can detect more, distance.
Right.
That's a different thing. We are actually concentrating on the processing power, not on the camera.
Yes, so that it's just like anything else. If you have a telescope, you can see the moon better with your eyes. So it all depends on the optics that you're attaching to the processor.
Right. Yeah.
Very, very, very cool. So ArchiTek, ARCHITEK.com?
.ai.
And you guys are looking for B2B partners, integration. What's the goal?
Well, B2B, because we make the chip and it's a device.
Sure.
So it doesn't run by itself. We of course provide the software to run it.
Yeah.
So, but it has to be put into products. It could be put into security cameras, as I said, or it could be even put on drones. It could even be used for automotive autonomous vehicles.
Sure.
We actually can even run application which can take your car and tell it where it is at every moment and make a map around it.
Where's the company based out of?
We are based in Japan, actually.
Japan, oh.
Yes. So we are here from Japan.
Okay, fantastic. Awesome. All right, everyone, ArchiTek, and we've got Hassan here, and of course the CEO is doing the Suichi Takada. So, domo arigato. Thank you much for coming.
Thank you.
Yeah. All right. Yeah. Thank you so much.
Thank you.
TPN CES 2022 coverage is executive produced by Michelle Mendez. Technical directors are Kurt Corliss and Adam Barker. Associate producers are Nancy Ertz and Maurice McCoy. Interviews are edited by Joe Minnie. Hosts are Marlo Anderson, Todd Cochran, Scott Ertz, Christopher Jordan, Danielle Mendez, and Alante Sparks. Las Vegas studio provided by HC Productions. Remote studio provided by PLUGHITZ Productions. This has been a Tech Podcast Network production. Copyright 2022.